This is section 6.3, problem number 10. We're not going to use the actual solving the system using Gaussian elimination and matrices, just because it's a different way to solve the problem. And on a test or a quiz, you can solve it any way you want. So I don't want to teach you a different way of doing the same thing. So let's just review what we learned before. So remember, step one is to choose any two equations. I am going to choose the first and the second equation. So the first equation is 2x minus y plus z equals 8. So I'm going to choose that first equation, 2x minus y plus z equals 8. Now I want to eliminate the x. That means I'm going to have to take that second equation and multiply it by a negative 2. So I'm going to go ahead and do that. So I'm going to multiply the second equation by a negative 2 and distribute that to everything. So that gives me a negative 2x plus 6y plus 4z equals 2. Now I add these together. Notice when I add those together that the 2x and the negative 2x is 0, so that's gone. And then I've got 5y plus 5z equals 10. Oh, how great. Notice that everything there is divisible by 5, so I'm going to divide both sides of the equation by 5 and simplify that equation. So I get y plus z equals 2 and circle it so I can come back to it later. All right, now I'm going to choose equation 2 and 3. And for equation 2, I'm going to multiply that by 4 this time. So for the second attempt, I'm not going to use the negative 2 anymore. I'm going to multiply everything by a negative 4 so that the negative 4 and the positive 4x will reduce with each other. So when I distribute that, I get a negative 4x plus 12y plus 8z equals 4. And then the third equation is 4x plus 5z equals 23. And I'm going to add those together. I get 12y plus 13z equals 27, and there's my second equation. Now, step 3 is to put those two together. So I'm going to bring down the 12y plus 13z equals 27. And I'm going to take the second equation and I'm going to multiply it by negative 12 to eliminate that y. So when I do that, I get a negative 12y minus 12z equals a negative 24. I add those two together, and again notice that the 12y and the negative 12y is 0, which is what I wanted to happen. And then 13z minus 12z is just z, so z equals 3, and now I have my z. And step 4, start back substituting. So I'm going to take the y plus z equals 2 and substitute in z, which I just found. So I'm going to substitute in z, which I now know is a 3. So I get y plus 3 equals 2. Subtract 3 from both sides, and I get y equals a negative 1. There's my y value. And now I'm going to go back up to the top and choose one of those equations to find my missing variable, which is x. So I can go into any one of them. I'll go ahead and go into the middle one. So in that middle equation, I'm going to substitute in the y and the z that I've found. So I've got x minus 3 times y, which is a negative 1, minus 2 times z, which is 3, is supposed to equal negative 1. Negative 3 times negative 1 is positive 3. Negative 2 times 3 is a negative 6 equals negative 1. 3 minus 6 is a negative 3, so x minus 3 equals negative 1. add 3 to both sides and get x equals 2. And then, of course, I want to substitute those back into these 3 equations and make sure they work, which they do. So my solution is the ordered triple. X is first, 2, y is second, -1, and z is 3. And there's the solution to this system.